Lecture number 1, what is chemistry? So this semester we're going to be talking about chemistry. We're going to start from the very beginning. We're going to go through more and more complex items. But we need to start with talking about what actually is chemistry. So let's define chemistry. Chemistry is defined as the study of matter and its changes, as well as the energy associated with those changes. So we're taking this matter, which we're going to talk about, define in a minute, but stuff, and we're changing its form, changing it from one thing to another. That primarily is chemistry. Right? The other thing that we're looking at is following the energy that it takes to cause those changes to occur, or if a change occurs, what's the associated energy. All of that is chemistry. So when you think about it in very general terms, that chemistry is the study of just about everything. Right? We're changing something from one form into another and following the amount of energy it takes. Typically when we're talking about chemistry, or at least when we will later, we're talking about it at a very small scale, but we're really talking about things, matter, anything, stuff. So let's take a second and sort of subclassify this thing. You'll see here in the slide that we can classify this matter into a variety of different things. Right? But when we talk about the chemistry of matter, let's take a step back and first talk about what is matter. So matter is anything that has mass and takes up space. Right? So like the desk we're looking at, computers, you and me, anything that has mass, right, or takes up space, and takes up space, is considered matter. Right? Here on the slides you can see we have the three common states of matter. We have on this side we have the solid, right? Things that are typically solid. If we think about them in terms of atoms, we'll talk about what atoms are later, but the small components that make up this matter are really close together and they are essentially stationary. They don't change location at all. Right? So all of matter, when it's a solid, has a definite shape and a definite volume. Right? The next state in the middle here is the liquid state. Right? We're all familiar with liquids. They don't have a definite shape. They sort of take the shape of whatever container they have, but they have a definite volume. Right? And if we look at those smaller components, they're free to sort of move around each other. So we've sort of increased the amount of a possible movement of those small particles. Right? And finally, the last state of matter is the gas. Right? Now we've sort of separated these smaller components from each other by a large amount. The volume is dependent on the container we put it in. The shape, again, is dependent on the container. We've essentially separated those components from each other by a great distance, but they're now free to move in whatever direction we have. And we'll talk more about these individual states later and what those means on the smaller scale, but right now we just need to talk about matter. It's anything that has mass and takes up space, but we can be talking about a wide range of different states, from a solid to a gas. All of those are considered matter. We can classify or subclassify matter into these two different forms here. We can have a pure substance, which is sort of the most primary form. It can be, if we break it down into any smaller components, it's going to change what it is. We can take those pure substances and combine them, and we get what we call a mixture. It's a combination of these pure substances. Right? So pure substances, and which the mixtures we can break apart into pure substances, is going to change what the mixture is, but those pure substances themselves aren't going to change. The pure substances stay the same until we break them apart, and then we have something different. Right? Difference between a mixture and a pure substance. Right? If we jump further here, we can see this whole thing. We can subclassify those pure substances into the smallest component, which we call the elements, the smallest type of matter. We'll talk more about what those are in the next chapter. Or we can combine those together, those elements, those small particles together to form compounds. Both are classified as pure substances. Right? So an example of an element would be like gold. Right? If we break gold down any further, it's going to change what it is, and it's no longer going to be gold. A compound, for example, would be like water. Right? It is more than one. Water has hydrogen and oxygen in it, more than one element, but we can't break apart water into the hydrogen and the oxygen without changing what it is. Right? We can change its form or its state, but we can't change its actual identity. Right? If we look at the mixtures, though, the mixtures, they can. We have two different classes. We have the heterogeneous versus the homogeneous. The heterogeneous is a mixture that we can tell, if we look across the mixture, we can distinguish one property from another. Right? So we can see the parts of this mixture that are different. Right? Example, swirl ice cream is sort of my tastiest example of this. Right? Both of them are ice cream, but we can distinguish the two types. Right? We have vanilla and chocolate, and mix them together, but it's still ice cream. The other type, this homogeneous mixture, is not that way. It's the same throughout. So if we look at, say, a cup of coffee, no matter where you sort of look at that cup of coffee, it's still coffee. To distinguish these, we can do it by eye, but there is some scaling issue. So if we look at, for example, milk, in the milk jug, it looks like it's all the same. No matter what portion of the milk we look at, it looks like milk. Right? But if you get into a really small scale, we see that this is a heterogeneous mixture. We have some fat molecules, this is milk fat, and then we have water. Right? So at a very small scale, those are different. So we have to be concerned a little bit when we're talking about these mixtures about the scale we're referring to it. Right? But in general, if we can go throughout the mixture and it looks all the same, that is a homogeneous mixture. If not, then it is a heterogeneous mixture. Right? We can then break apart these mixtures into these pure compounds, typically by doing a separation which we'd classify as a physical change. Right? A physical change changes some property, but not the overall composition. Right? So if we take something like water melting, that's a physical change, right? It's changing its sort of property, going from a solid to a liquid, but it's not changing what it is. Right? Same thing we can talk about here when we go from these mixtures to these pure substances. We can pull apart those two types of ice cream, right, to make vanilla versus chocolate. We haven't changed them, that we've just sort of separated them. So these physical changes, we're just changing the sort of the physical property, not necessarily the composition. Where if we look over here, going from a compound to an element, to break water apart into its smaller components, we are changing what it is. We are no longer, at that point, if we undergo a chemical change, we are changing the identity of that compound, or that thing. Right? So if we talk about steel rusting, right, iron goes from iron to iron oxide, we are changing what it is, therefore that is a chemical change. Right? So chemical change changes the composition, a physical change just changes its appearance, some sort of physical property, not necessarily what it is. Right? But what we're going to be doing when we talk about chemistry is we're going to be looking at these different things, pure substances versus mixtures versus compounds, and looking at primarily these chemical changes and how we can undergo what happens when we change those things chemically.
Dad, I done did it.